Yes, Govind sir, you can proceed.
Okay, sir. Thank you, sir. Good evening to one and all. Dear participants, I welcome you all on the Day 5 FDP program on advanced trends and innovations in modern life science. So now I'd like to invite Mrs. B. Lokeshwari, Assistant Professor, PG and Research Department of Biochemistry, Sacred Heart College, Tripattur, to introduce our today's resource person, Dr. P. Thirumalai Vasan, Assistant Professor, Department of Food Science and Nutrition, American College, Madurai, who going to present on the topic of nanotechnology applications in food science. Mrs. B. Lokeshwari, ma'am, now you can introduce our resource person formally. Thank you.
Okay, thank you, sir. Good evening to everyone present here. It gives me great pleasure to introduce today's distinguished resource person, Dr. P. Thirumalai Vasan, Assistant Professor in the Department of Food Science and Nutrition at the American College, Madurai. He is a highly accomplished and a researcher with over 2 decades of experience in teaching and research. He holds a doctorate in biotechnology from Vasan University and has specialized expertise in microbiology, biotechnology, food microbiology, immunology, and bioprocess technology. Prior to his current role, he served with distinction as the head of the Department of Biotechnology at Srimath Andavan Arts and Science College, Autonomous, Tiruchirappalli. He has made significant contributions to the field of microbial and bioprocess biotechnology with 53 publications in reputed national and international journals, over 800 citations, several book chapters, and patents to his credit. He has also guided research scholars at the MPhil and PhD levels and has successfully coordinated and participated in multiple funded academic and research programs. He is recipient of several prestigious honors including the Best Teacher Award, Best Performer Award, and the Eminent Scholar Award, reflecting his commitment to excellence in teaching, research, and academic leadership. He is also an active member of professional and scientific bodies and serves as an academic editor for an international journal. We are truly honored to have such an eminent scholar with us today. I am confident that his insights and expertise will greatly enrich this program. With great pleasure, I invite Dr. P. Thirumalai Vasan sir to address the gathering. Sir, kindly proceed, sir.
Thank you, ma'am. Thank you for your
Okay,
introduction. Thank you, yes, sir, for giving your opportunity. Good evening to all. This voice is okay?
Yes, sir. Yes, sir.
Okay, thank you. Okay. Good evening to all. Today we are discuss about the nanotechnology applications in food science. So most of the researchers will be using the nanoparticles in our experiments and all the research work. But my research area is nanoparticles applied in food science. So we are trying to some of the publications related to nanotechnology application in food science. One of the paper was published in the research journals. Other journals are communicated. Okay. So this is a short introduction about the nanotechnologies. So what is mean nanoparticle means? This is the small scale, is between 1 to 100 nanometer size. Is approximately 60,000 times smaller than within the human hair. At that, the important property is of the nanoparticle is the bulk counterpart enhance the chemical activities, superior mechanical strength, improved bioavailability, and the extraordinary sensing capabilities. This is an important property. So most of the research work will be doing the research work in the nanotechnology. So, what is the main role in the nanoparticles in the food science? The mainly for the real-time detection The maximum, most of the researchers work in the nano biosensor. Will identify the purpose of pathogens, toxins, as well as allergens in the food products, and smart packaging alerts like contaminations of indicator the contamination or spoilage to detect and preventing the foodborne illness. And also the main agenda of nanoparticle is the extent to the shelf-life period. This is the main agenda. So most of the research work will focus on in the packaging material we use in the nanoparticles. In the nanotechnology food packing system, is the mainly we use the food packaging. The main property is the superior barrier properties because they have create the ultra effective barriers against the oxygen, moisture, and harmful UV effects, like also. And also the main purpose is the active preservation system also. And the main theme is sustainable solutions. And the main purpose is self-healing technology. This is the main purpose for the nanotechnology for using in the food packaging systems. So one of the another one of the application is the enhancement of the nutrition value, like nutrition delivery or using nano encapsulating technology, for deliver the vitamins, minerals, and also other nutrients for efficiency maximize absorption. And one of the other factors is healthier formulations. For example, the dramatically reduce the fat, salt, and sugar content is processed food while maintaining or even enhancing the taste, texture, and also consumer satisfaction. And the third factor is enhance the bioavailability. So bio means prove the body is able to absorb the utilize the nutraceuticals, vitamins, and dietary supplements to the advanced nano carriers. So what is the range? Why we are using that? Why we are using the nanoparticles? The main purpose is the main reason the global food challenges, the fertility supply chain intelligence. So nanotechnology is enable the sensors. This contribute the food integrity, temperature, humidity, contamination throughout the complex transport and the storage network. Another one of the reason is waste reductions and personalized nutrition. That means the nanotechnology delivery system, for example, encapsulation system. The nutrition solutions tailor the individual dietary needs for health conditions and the genetic profiles. And one of the most reason is agriculture enhancement. So nowadays, we maximum we use in the fertilizer to chemical fertilizer and biofertilizer. Nowadays, we using the nano fertilizer. The nano fertilizer and nanopesticides improve the crop yield and reduce the chemical usage and enhance the pest resistant and the promising sustain for the farming practices. So natural for nanoscale means the main purpose is natural nanoscale components. The many essential food components like protein, starch, and fat is naturally exist and function in the nanoscale, the forming biochem basis of nutrition. Second one is the traditional application. The common food like yogurt, cheese, and mayonnaise have a long life natural occurring in the nanoatoms to achieve the characters like texture, stability, and quality. And biomedical innovation means the modern technology will upon the enhance the enhance the natural process, creating innovation, the work in the harmony of the food ingredient by the molecular structures. Nowadays, maximum we using the nanotechnology. The marginal reason means the for the current challenge. Current challenge means the health and environmental impact of engineered nanoparticles remain under the intensive scientific reasons. Second, the existing regulations. Third was the limited understanding of long-term exposure effects. So this is the fourth means the growth calls comprehensive international standards and harmonized regulatory framework, development of the risk assessment methodologies, emphasis of transparency, mandatory labeling, and consumer education initiative. This is the current emerging trend. So nanoscale revolution means the first one is the comprehensive transformation. The revolving every aspects of food system to form the safety protocols and the quality assurance to nutrition enhancement. And the second one is the global security. For example, the project means that 10 billion people efficiency sustainable up to 2050. And the responsible innovations and the revolution is here. The nanoscale revolution is effectively reshaping how to reduce the production of structure like enjoy the food and they're transforming the entire food ecosystems. So one of the application is the delivery system, like a nano encapsulation system. So nano encapsulation means that it is one of the main applications in food science is the bioavailability of change in nutrition. What is the problem? Why you are using nanotechnology? So problem means the essential nutrients, including vitamins, minerals, and antioxidants, have obstacle for the human body. Poor solubility, chemical instability, and the limited absorption range. So it's prevent of the gaining their full health benefits. This is the problem. So they mean the when we're using the nanoparticles, the enhancing the viability is the concern, the maximizing nutritional impact, and advancing disease prevention strategies. When nutrition is more readily absorbed and utilized by the body, we unlock the potential support of immune system and cellular health and the overall wellness. This is a game changer in the food science. So one of the reasons is nanoscale precision and production enhancement and target delivery. So nanoscale precision means the nanoparticle range is 1 to 100 nanometer. Its external properties including the high surface area. So we will include the improve the solubility, enhance the chemical stability also. Production category is the nano encapsulation system. So it's create the productive barriers like vulnerable nutrients, shielding them the environmental degradation. So will be a product from the environmental as well as other nutrient factors. Target delivery is one of the reason. So this is a system enable the target delivery is controlled release bioactive compound throughout the gastrointestinal tract. Is optimizing absorption at the cellular level. So the food science was the maximum we mixing with the nanotechnology particles. So that's why they mentioned that the game changer in the food science. So this is what are the types means there is a some of the types is there. One of the types is liposomes and nano emulsions. So this is the vesicle. This is a pine droplet system that encapsulates both water soluble and fat soluble nutrition. Non-gel system is like a three-dimensional system. The network with natural polymer-based nanoparticles that provide flexible, biocompatible delivery systems. Enhanced cell uptake means these systems improve the encapsulation efficiency and protect the sensitive compound from harsh environmental necessity to enhance the cellular absorptions. So impact of nutrition and bioavailability means that a 300 percentage the bioavailability increase in the process is possible. So the average improvement, the overall bioavailability will be around the key vitamins like 300 percentage is the bioavailability increase. 80 percentage of thermal stability also increase. It means heat resistance. The 4.2x water solubility is improved the factor for overly soluble bioactive compounds. And also the clinical studies that demonstrate the nanosystem the provide the superior thermal stability, water solubility, and temperature sensitive nutrients. So this is the major applications in the nanotechnology in the food science. The real world application like nowadays, functional foods, agriculture innovations, and product integration. Functional food means that are fortified with the nanoparticles with the that means antioxidant with nano food material with the antioxidants like omega-3 fatty acids or other some chemicals. Agriculture innovation, we're using nanofertilizer and nanopesticides. Product integrant will use the food product in formulation that is into the beverage, dairy products like bakery items and also other etc. So sometimes we can use the nutrition snacks also for enhance the health benefits. The safety. Next one is the main reason is safety. So the addressing critical challenge because the toxicity is the one of the most important factor for using the nanotechnology. So evolving regulatory framework and biocon materials focus on continuous monitoring is also essential because we use in the food item. So the safety and regulation is more important. The future prospect of innovations in this sustainable manufacturing, personalized nutrition, and smart integration. So some of the people we can using with anyone who have been working with nanoparticles. This is the area for the delivery system. So next generation by use sustainable nano manufacturing enabled scales of eco-friendly production method or green chemical method also. Personalized nutrition means the delivery system which fail the individual genetic profiles, metabolic needs, and the health conditions. Smart integration with the health platforms, intelligent packaging, the real nutrition smart in the freshness of tracking or personalized consumption of recommendations. Next one is the nano enhanced antioxidant of fruit vegetables. The innovations of that, the vulnerable polyphenol and some of the compound will be implemented and will enhance the antioxidant property with the fruits and vegetables. So this nano enhanced population means demonstrate the significant potential to reduce chronic disease like risk factor, cardiovascular disease also. Then the nano revolution in the three categories is future. One is transformation progress, safety, and sustainable futures. Next one of the major application is nano preservatives and antimicrobials. So most of the researchers will be working with nanoparticles, silver nanoparticles, like using antimicrobial property. So this is application, one of the main applications. So in global food safety means 600 million people will suffer annually, and 400 cases annual death, and 50 to 20% of food loss rate. So we will using the prevention factor. We can using the prevention factor. The fall for actually contaminated food is there. Overwhelmingly is the main problem. Is according to the result is WHO result. So the microbe resistant continues to grow. Spoilage remains the persistent challenge also, and consumer is engaged in the demand of natural, clean, labeled ingredients. So industry needs a revolutionary approach. So nanotechnology, we're using one of the preservative agents. So why nanotechnology for using food item? It is the enhance the efficiency and control delivery and versatile integration. So that's why we're using the nanotechnology particles in the food systems. The one of the majorly we're using particle is the silver and metal oxide particle is powerful. It's an antimicrobial property. Silver nanoparticles, most of them researchers will be using silver nanoparticles. Is approximately 21 nanometers effectively inhibit the dangerous gram-negative bacteria, including E. coli, Salmonella typhi, and Vibrio cholerae. Metal oxide like titanium oxide, zinc oxide, and copper oxide is demonstrated exceptional antibacterial and antifungal properties. Multiple mechanisms sometimes is compact with different combinations. So its compact microbes through membrane disruption and reactive oxygen generation is powerful in the biofilm inhibition also. So that's why we use in a silver nanoparticle or other nanoparticle we use for the food items. So nanocompost packaging system. So what is an active packaging is one of the main observation. So enhance the barriers, sustainable solutions, and intelligent monitoring. For suppose we're using a nanoparticle by nano delivery means, what is the challenge? Means the food-derived antibiotic peptides and plant-based extract is natural preservation, but face significantly stability to control the leach change in the traditional formulation. So one of the recovery solution is nano solution. So nano solution we use nano emulsion method and advanced encapsulation technology to protect these dedicate the natural agents, dramatically improve their dispersibility and potential to enhance the precise control over time. So real application commercial packaging system. Another one is animal peptides. So commercial packaging system is the nano enabled packaging film or now commercially is available. What is the purpose of nanoparticle replacement packaging? The main reason is reducing the microbial contaminations and significantly extend the shelf-life period of fresh produced meat and dairy products. And one of the properties, antimicrobial properties. So antimicrobial property means the nano conjugated antimicrobial peptides show exceptional promise as a natural preservatives with the minimum risk of microbial resistant development. So this is the main reason for using the. This also so most of the researcher will be successful story for using the nanoparticles in the package systems. Again, we're using the same categories: migration monitoring, elimination studies, and transparent testing. So, what is the reason? What the reason means? The nanoparticle is migration from packaging material to carefully measure and strictly regulate to minimize the consumer exposure and ensure safety. So that's why, because the reason is the toxicity is one of the reason. So transparency, this means the testing protocols like transparent communications to critical the building public trust and achieve regulatory approval worldwide. The future of food preservation. So there is a three category. Suppose anyone working with nanoparticle as a food preservation material. One is biodegradable integration. Like integration nanotechnology particle with the biodegradable material is address both in environmental sustainability as well as food safety challenges simultaneously. Second category is multifunctional packaging. It means next generation packaging is combined with anti-meal protections, anti-acid properties, and the real-time spoilage sensor in a significant intelligent system. So nowadays, my project PG project is working with these two areas, but this is the time duration will be length because immediately you not get the results. So nanopreservation and transform food self-sustainability is compact pathogens. That means they provide the powerful tools to effectively combat food pathogen and prevent spoilage in the molecular level. And natural enhancement is combined with natural antimicrobial with nanoderivative system. So dramatically enhance the efficiency is while meeting consumer demand for clean label products. And global impact, the continuous intervention with the rigorous safety assurance will have widespread adoption, reducing food waste and protecting public health in worldwide. Next one application is nanotechnology in food packaging. So food packaging means why you are using food packaging is demanding growing demand. For example, the global food demand is projected with rise to 70 100% by 2050. Is a creating unprecedented pressure and preservation and safety system worldwide. Current limitation: the traditional packaging materials is tackled with spoilage prevention, micro contaminations, and the mounting environmental concern from plastic waste. So, the food industry is urgently need the innovative solution to extend the shelf life, to ensure quality, and address the sustainable challenges for a population to grow the worldwide community. So, nanotechnology means we're using a food packaging system. One is nanoscale engineering. So, manipulation of material like 100 nanometer scale, 1,000 of times, is smaller than human. Also mentioned that to create enhanced properties. Superior property means this deliver the unique mechanical strength, antimicrobial activities, and exceptional barrier function is impossible larger scales. The smart system it enabled the development of active intelligent packaging that responds environmental changes and food condition in the real time. So nanoparticle transforming is already we discussed about the antimicrobial agents like silver oxide and zinc oxide. Structural reinforcement means the nanocellulose and the starch nanoparticles dramatically improve the mechanical strength, flexibility, and moisture resistant in food packaging films. Third one is enhanced barriers. So nanocompost create the superior gas barrier properties, UV protection, and overall durability that keeps food fresh significant longer. One of the applications is active packaging. So wine is fighting spoilage and contamination. So access quenching and microbial incubation and the control rates is already we discussed. So in other words, intelligent packaging, the real-time food quality monitoring, contamination detection. So this is the current emerging technology. The contaminant detection, the nano sensor is identify the microbial contaminations, toxins, and harmful gas emission inside the package with the unprecedented sensitivity. So in our India, we were not using with packed chicken or meat something, but the abroad is the major issues like Clastic botulinum is the major foodpath pathogens. So the death rate is high. Is compared with other countries. So the contamination reduction is one of the most wanted technology for the identification of microcontamination. So second category with the reason is enhance the traceability. Nano barcodes and smart indicators improve the supply chain and tracking the booster applications. And one of them is early warning system. Sometimes the food will be changed as stick conditions or the change the pH or some temperature or whatever. So the early warning system is most important. Suppose we're using nanotechnology with for packaging system. So one of the current technology. So the packaging alert is consumed the alert the spoilage and before visible sign. Sometimes we're using sensor system to indicate the change of color or something whatever. So it means it's preventing the foodborne illness and the reducing waste. So sustainable body nano packaging mean is one of the eco-friendly innovations, performance enhancement, and the environmental impact. Eco-friendly innovation means the integration of nanoparticles with the biopolymer that create the compelling and alternatives to traditional petroleum-based plastics is addressing the environmental concern. And the performance enhancement means the nanoparticles dramatically enhance the mechanical and barrier properties of biodegradable film is overcoming the previous limitations in the plant-based materials. So we're using biodegradable means they are to 60% of potential reduction will be a possibility, and 40% of improved the biodegradability and 3 to 6% a month to decompose. It's possible. So safety regulation means we are working with again we use migration of property, regulatory body like PDF approval, and the nanoparticle will establish strict guidelines for the product applications. So the current research is ongoing studies focusing balancing innovation benefit for the customer health protection and long-term safety monitoring. So market impact of future output means the rapid growth is trajectory. And if we're using nanotechnology is driving packaging system market, it's projected to grow exponentially, the reaching tens of millions in value within the next decade. The next generation innovation, the innovations of nanosensor system and smart packaging will be dominate the next wave of food safety technology and the consumer protection. The third one is the global supply chain revolution. These technologies have a potential to transform the worldwide food distribution, dramatically reducing the waste of the particle. The nanotechnology is promising for packaging, like one of the reason extend the shelf life period, enhance the safety, and the sustainable future. So extend means what does it mean? Extend shelf means we reduce the contamination level. So and also enhance the safety means prevent the food pathogen like toxins also. So sustain means the biodegradable property. Next category is suppose we're using a packaging system or something whatever. The main of thing is safety, toxicology, and regulatory aspects of nanotechnology in food science. The one is nanotechnology. The reason is it's a double-edged facts of unique toxicology challenges. One is migration and exposure, toxicity mechanism. These multiple pathway cellular harm is include the oxidative distress relation, inflammatory response, genotoxicity, and the disruption of normal cellular functions. And environmental concern is the accumulation of soil and water system. The bioaccumulation means it's infected the food chains also. The research in the graphene oxide particles. The demonstrated the size of an independent toxicity is profiled. Particle size is 400 nanometer. Is exhibit significantly greater adverse effects of cellular system is compared to the large variants. Invisible risk like nanoparticle migration and exposed pathways. The one of the case study, the FDA approach to the nanotechnology bodies is the case by case assessment. So FDA regulations of nanotechnology's product is under the existing legal framework for evaluating safety. Individual is based on unique nanoscale properties rather than applying calculations. Science-based evolution, there are no presumption of safety to harm. Each nanomaterial undergoes the rigorous scientific evaluation to alter the biotechnologies. And third one is advanced research tools. FDA is the National Center for Toxicology Research also. Is developed the cutting edge detection method to quantify nanoparticle and to conduct the comprehensive toxic studies also. The global regulatory prosperity with the gap. The United States, voluntary industry guidelines is predominant, risk-based assessment approach, no mandatory labeling requirement for nanoparticles, and focus on post-mark surveillance. And other countries like Europe and Canada, is proactive regulatory framework, modern nano-specific safety assessments, consumer labeling requirement is enforced, and precautionary principles applied. The critical challenge is the inconsistent definitions of nanoparticles across jurisdictions. Difficulty to regulate complex multi-component nanostructure, gaps in long-term safety data, is called the principle until the safety is conclusive. So toxicology research at FDA, the one is studies genotoxicity studies. It's investigated the DNA damage, mutagenic potential, and nanoparticle use for food contact applications. Systematic distribution tracking how nanoparticles is moved throughout the biological systems and accumulate with the specific organs. Third one is the organ specific toxicity. So these three research will be in the FDA NCTR. One of the case study of silver nanoparticle food packaging system. The silver nanoparticles are among the most widely distributed nanoparticles in the food packaging due to their powerful antimicrobial properties or the inhibit the bacterial growth. So the significantly reducing the spoilage to extend the product shelf life. Approximately the 70% bacterial loss inhibition by using several nanoparticle in food packaging. 40% will be shelf life will be extension, and 15% will be market global growth. So balancing the innovation and safety pathways, matter regulations, transformations, engagement, research, investment. So nowadays is the biggest issue. So most of the research will be a proposal will be based on some time, like 4 to 5 years, 4 to 5 years before. So most of the research will be using the nanotechnology, like physics, chemical, biochemistry, and all of the research will be approached with DPDDST. We'll be using a nanotechnology particle, but nowadays the fund will be reduced. What is the reason? I don't know. So international collaborations is needed now. So development harmonial frameworks like across the border to create the consistent standard to protect the global food supply. So navigate to the frontier food safety means the transformative benefits, complex challenges, and the essential safeguards. So nanotechnology is a material is opportunity to enhance the food quality, safety, and sustainability across the entire supply chain. What challenge is that? So that's the reason. So the promise of nanotechnology in food science to enhance the food safety level. In market value in 2023, $352 billion is acquisition nanoparticles global evaluation. The project score is 869 billion in project by 2031. And the 147% growth is great, is explosive, expansion of overnight year. Because the reason, the sustainable agriculture reason, that we are using nano fertilizer and nano pesticides to boost the crop yield. So that's why the growth rate will be enhanced. So evolution food packaging, real world examples, nano oxygen indicators, sometimes we use near-term or direct spoilage systems. Carbon nanoparticle will be used to inhibit the salmonella growth in the meat products, cellular production, permitting the antibiotic productions. In the health and safety concern, the unknown risk, like toxic ocean, whatever goes in, the unique nanoscale properties create the unprotected interaction with the biological system, raising the concern about cellular toxicity and bioaccumulation in human tissues over time. Now, the second one is cellular penetration. It's both the ability to cross the biological barriers to penetrate human cells. It's potentially cause unfrozen biophysiological effects sometimes. Regulatory gears. So, no unified global standard to exist in nanoparticles using food products, supporting inconsistently safety protocols and approval process across the different countries. Environmental impact and soil growth challenge means that ecosystem disruption, not the reason. So nanoparticle may alter the sometimes we alter the soil ecosystem is affecting beneficial biodiversity and long-term soil fertility also. Chemical imbalance is overuse of nanoparticles that creates the risk of soil acidification, salinification, or dramatically biodiversity loss of organic landscapes. Sustainable impressive, urgent need of for sustainable management practices to prevent the irreversible long-term ecological damage to food production systems. Economical and scalability barriers means the high production cost. The complex synthesis method, the specialized equipment is needed. So analysis is also is called. The regulatory uncertainty, the uncleared approval pathways and evolving safety levels is also nowadays the biggest barrier for the nanoparticles. So the third one is scale-up challenges. So small-scale laboratory success are frequently to fail the translate to the cost-effective, but in the fail in the mass productions. Consumers awareness education means the public competition means growing concern with about the perceived unnatural instance and safety fears that create resistance to nano-enhanced food product consumer products. Transparent the gaps, ethical debates, controversy intensely where genetic modification is combined with the nano-driven system, raising complex with more questions. In case study of South Arabia, the focus about food security challenge. For example, 80% food product will be imported. So it depends upon the external source. And only 20% is locally reproduction. So suppose we using nanotechnology with the safety guideline, the transformed effect potential is boost up the local food productions. So towards the solution, what is the so most of them will be discussed about the risk factor and also safety precaution. So what is the solution? So one of the reason is international harmonization. So develop with unified regulatory standards and rigorous safety testing protocols. Green innovations like producing nanoparticle using non-sustainable with using green synthesis methods. And third one is interdisciplinary research, which with nanotechnology, toxicology, environmental science, and food science through collaborative studies is also needed. So, what is the conclusion of my research? The nanotechnology holds the transformative potential for food safety, security, and sustainability, but only through the responsible development. The present challenge is health risk, environmental concerns, economic barriers, ethical debates, or demand the urgent attention. The future, throughout the responsible innovation, nanotechnology can safely revolution global food system fusion. So, what are the future means? Digital integration, it's the connection with the precision agriculture, ICT device, intelligent supply with chain with the system for end of the optimization, sustainable material like development of multi-national nanoparticle with enhanced food safety level, personalized nutrition is like expansion of customized nutrition solution and interactive foods with adapted individual health is needed one. Market expansion, like projected exponential market growth is devising is the consumer demand to for safer, healthier, and more sustainable food options. Okay, this is my recent publications. So nowadays, working with these areas, and thank you for your.
So, dear participants, you raise your questions in the chat box.
If you have any question, type in the message. Okay.
So one question, sir, from Dr. S.K. Jasmine Saina. So good evening, sir. Could you please clarify on the following toxicity issues are high with the use of inorganic nanoparticles like silver and other metals? Keeping this in mind, is it still safe to use nano-enabled food products for long-term consumption? Sir?
Sir, 2 minutes, sir.
Dear all, let Govind sir, am I audible?
Yes, sir. You are audible.
Okay, let's wait for the speak. Yes, Thirumalai
Sorry,
sir.
sir.
Yes, yes. Please proceed, sir.
Yes, sir. Okay, this is a very important question, and also sometimes we're using some inorganic nanoparticles, which especially silver, zinc, oxide, and titanium oxide as the other nanoparticles can show the site of toxicity, oxidative stress also is bioaccumulation is possible in laboratory studies. So, however, the food applications like encapsulation food grade system, immobilized packaging material is bound the delivery system is also is work is nowadays will be work out. But the long term consumption, some of the risk is there. Like toxicity studies is more important. Suppose if suppose we're working with any particle with any nanoparticle with the food system, the toxicology study result is more important, and almost cell culture results are, result is more important. So health risk is possible.
Thank you, sir. Any more questions from participants side?
Govind sir, I would like to add some points with our resource person.
Okay, sir.
Dr. Jasmine Madam is asking about the toxicity issues. I endorse with the statement declared by our professor resource person Thirumalai sir. As the ma'am's question was a very clear, cut and clear question. Ma'am is asking about the clarify the following. What about the toxicity issues are high with the use of inorganic nanoparticles? As ma'am pointed out, as our resource person give the example about the silver nanoparticles or gold nanoparticle or platinum or copper, these inorganic nanoparticles come to the market and give its application. When the prolonged usage, it also give the toxicity accumulation. With reference, if you take the example as a nano fertilizer, then researcher go and approach about the organic nanoparticles. Nowadays, I would like to take the example of chitosan nanoparticle. Nowadays, bulk compound converted into nano size, and it was used as a organic nanoparticles with the backbone of carbon nowadays, which take care about the positive application of the nanotechnology. As ma'am's question we give the clear picture, the still safe to use nano enabled food products. While we are talking about the food products, of course we have the issues. For example, I will take paracetamol. We people use for long term. It is prolonged usage, it leads to liver damage. Similarly, long term usage, not only nanoparticles, all kind of chemical compounds which causes the toxicity. Nowadays, in olden days, people used to work with the application of the nanotechnology in positive way. Now researchers working on the toxicity behavior and the demerits associated with the nanoparticles. As we have some time, that's why I take some advantage of answering the question raised by our honorable participant. We have some time, that's why I take some advantage. Now we can proceed with other question raised by fellow participant. Then we can move on to formal valediction to be take care by our convener Dr. Pungode madam. We have some question. Over to Govind sir.
So one more question from Dr. Nitya Devi Prem Kumar. She asked that nano applicators are also available and also used in the markets. Sir, are you there?
Sir, so next question. The major, sometimes we're using cold nanoparticles by using direct pesticides for artificial colors and fruits and spices is also available. Silver nanoparticle for identifying the bacteria, and carbon particles are heavy metals for using mercury is also. So the nano strips is also there for using the quick checking of milk adulterations. Urea detergent formula is also there.
Okay, sir. So thank you for your clarification. So any questions?
Sir, is one more question from Sumaira Rafiq. I don't. She's
Okay.
first time asking. Please read.
Yes, sir. From Sumaira Rafi, can nanotechnology be used in checking food adulteration, sir? Food adulteration.
It's possible, sir. It's possible, sir. So the major sometimes direct detection or indirect detection is possible, sir.
Okay. So again, Dr. Nitya Dev Prem Kumar asked, what about copper and zinc nanoparticles?
Sir, Govind sir,
she-
sorry for the
Pardon?
interference. Regarding the previous question, I will add some points along with resource person
Yeah,
regarding
sure,
the food.
sir.
Regarding the adulteration, ma'am is asking about the adult. So regarding
Food adulteration.
food adulteration. So actually, where is that question?
Can nanotechnology be used in checking food adulteration?
One second. Food adulteration. Yes, your question. I cannot able to find the chat box. Nowadays, nano sensor plays the important role. For example, I quote with the pH paper. Previously, we are using the litmus paper to check the pH of the solution. Then we move on to pH meter. Nowadays, we using the pen type pH meter. Like if you want to check the food adulteration, sensor based nano sensor papers are available nowadays. These nano sensor based paper can able to check whether unwanted components or adulteration chemical which is present in our food as additive agent can able to check by using the nano sensor. Thank you.
Ma'am, one more, sir. The copper nanoparticle were using nanosensor
Yeah.
for detecting pesticides, artificial food colors, toxic chemical, and biotic contaminations. Is a measurement is possible, sir.
Yes.
And zinc oxide mean we using zinc, milk adulterations, heavy metals and microbial toxins is possible, ma'am. One of the my research scholar been working with in about 4 to 5 years back. Been working with the zinc oxide nanoparticle. But mainly we using the Daphnia, the freshwater indicator system. Because why you are using, because the cosmetic system, most of the zinc particle will be used in the cosmetic. So you have a high toxicity level. So that's why we using the Daphnia for the freshwater indicator system for the zinc oxide nanoparticles.
Okay, sir. Thank you, sir. Thank you for your clarification. So, any more questions, or we end up this for a valedictory? Yes, sir. Shall we go for the valedictory?
Yes, please proceed, sir.
Okay. So now I'd like to call Dr. our A. Pungodai, our PG head, to deliver our valedictory address for the uh, FDB program. Now, please proceed, ma'am.
Thank you, Govindan sir. Good evening to everyone. So the 5 days online FDP program on advanced trends and innovation in modern life sciences was successfully conducted from 6th January to 10th January 2006 for featuring and eminent expert from academic and research institutions. The program initiated with an inaugural lecture by Dr. M. Pungodai on food and mood, highlighting the biochemical link between nutrition, neurotransmitter, and mental well-being. Subsequently, sections covered cutting the huge area, including vaccine development technologies, Dr. S. Jagannathan, microRNA mediator regulations of intestinal ion transporters, Dr. Arivarasu Nadarajan Anbalagan, biotechnological potential of lichen as biofactories, Dr. S. Senthil Prabhu, and nanotechnology applications in food science, Dr. P. Thirumalai Vasan. The FDP provide a multidisciplinary platform for knowledge in exchanging, fostering innovation and academic enrichment. The organizers express the sincere gratitude to all the resource persons, organizers, and participants for their valuable contribution and active engagements, which ensure the grand success of the program. We look forward to meeting again in another enrichment FDP program. Thank you all once again.
Thank you, ma'am. So once again, I'd like to thank you, our patrons, co-patrons, our head of the departments, and our mighty faculty members, and all our dear participants for the successful completion of our 5-day FDP program. Thank you for your wonderful cooperation and support. Your participation certificates will be sent as early as possible. Thank you, sir. Shall we end up the session, sir?
Yes, Dr. Govindra. Thank you to Dr. Govindrajan, our organizing secretary, Mrs. Reshma, our another organizing secretary, Dr. Pungodai, the convener of the FDP, and organizing committee members, Dr. Fernandez sir, Dr. Sivelunga sir, Dr. Sheila madam, Dr. Gopal sir, Mrs. Lokeshwari, in absence Dr. Jayaprakash sir. From my bottom of heart, I would like to thank each and everyone, because I'm not, I know there is no formal vote of thanks, but we have 5 minutes more. From my bottom of that, I thank you all. So thank you to all the various stakeholders. Thank you. God bless you.
Thank you, sir. Thank you, ma'am.
Thank you, sir.
Thank you, Reshma. Thank you,
Thank you,
Sheila.
sir. Thank you. Thank you, sir.
Thank you, sir.
Thank you, all of you.
Thank you, sir. Thank you, sir.
Siva
Thank you, Thirumalai, sir.
Sir, Thirumalai sir. ரொம்ப நன்றி சார். Thirumalai sir.
Thank you, sir.
Thank you, all of you. Thirumalai sir. Okay, thank you, all of you. Thank you all. Thank you.
Okay, sir. Shall we end up the session, sir? Thank you, sir.
Yes, Govind sir. Thank you. God bless you. Thank you, sir.
Thanks.